All right, here we are in section 1.7, which is going to be reviewing how do you solve quadratic equations, and we're going to take a look at a couple different ways that you can solve them. This is taking a look at the algebraic way of solving it, just kind of the same way that we did with the absolute value. We are going to be spending a lot more time on the quadratic function once we get into our graphing unit, but these steps that we are looking at here are very important for us to be able to solve, just to do different types of equations. So one of the main ways that you should know how to solve quadratics is by factoring. That is going to be a big part of our time here spent in pre-calc. Okay, so just a reminder that when you are working with quadratics, quadratics do make that U-shaped graph. They do give us that parabola, versus when we're working with linear functions give us that straight line. A linear function crosses the x-axis at only one point, where a quadratic crosses at 2 points, making it possible for us to have two solutions. And we cannot just go the linear way of doing so. I cannot just, add 30 to both sides because I have a y squared and a negative 13y. Those are not like terms. There's nothing I can do with that. We have to result to other things. So we do have factoring. We also have using the square root property. We have also completing the square, which you did that in Algebra 2, and we are going to focus back on that today. And then last but not least, there is the quadratic formula, but that is going to be kind of our last result. Okay, so let's just do factoring first of all. We just did factoring a little bit ago, so hopefully you feel comfortable with that. But I would be able to break this equation down into y, and y will give me y squared. And then I could do a -3 and a -10. That's going to give me my, oh, whoops, sorry. I see that as a negative. Oh, I got to go back here. -30, not a +30. So actually, before I do that, as I was just double checking, as I was talking to you here, here's my red flag. -3 times a -10, that gives me a +30, not -30. So got to go back to the drawing board, and sometimes that happens. But one of these factors is going to be positive and the other one's going to be negative. And it looks like I'd be better suited to do -15 and +2. That will give me the -30. That will also add up to give me my -13. Now, I have factors. Factors mean multiplying. And the only way that I can get 0 when I multiply two things together is if one of those or both of them equal 0. So we do what's called the zero product property. We take each factor and we set it equal to 0. Now you're just going to solve. So y equals -2 and y equals 15. So now if I were to go back up into that factoring stage right there, -2 plus 2, well, that's 0. -2 minus 15, well, that's -17. 0 times -17 is 0. So that's going to work for us. If I also go back to that top equation here, I am going to get 0 as well. So it just kind of plays out for us in that situation. All right, let's take a look at number 2. If you are going to do factoring, one thing you'll do is you always need to make it equal to 0. So equation always needs to equal 0. That means I've got to subtract an 80 from both sides. So 2x squared plus 6x minus 80 is equal to 0. Something else to make your factoring a little bit easier is always try and see if you can take out a GCF. In this case, I could take out a 2 and be left with x squared plus a 3x minus 40. That makes our factoring much easier to work with. And negative 40, so I see a positive 3, so I'm going to go ahead and say positive 8 and a negative 5 will work for us. Now, I have 3 factors. I have 2, I have x plus 8, I have x minus 5. And when I look at these factors here, I can go ahead and, set them all. Now that if I do 2 equals 0, if I take x plus 8 equals 0, if I take x minus, well, not an extra line there, x minus 5 equals 0. The x equals 2, that I'm not worried about. Okay, number one, that can't hold true, but it doesn't matter because 2 times 0 will give us 0. So it doesn't hold anything for us. Here, I'm going to go ahead and subtract 8 from both sides. And so I get x equals negative 8. Add 5, x is going to equal positive 5. And there's our 2 solutions. All right, let's take a look at number 3. I've got to get it equal to 0, so I've got a 4w squared plus 10w equals 0. Now I can take a GCF out of here, so I can take out a 2 along with a w, right? Yes, I can. So I've got a 2w plus 5 then is equal to 0. That's as much factoring as I can do. So let's go ahead and take both factors and set them equal to 0. Divide, and I get w equals 0, 0 divided by 2. And here I'm going to subtract 5, and I'm going to divide by 2. So negative 5/2 is our solution. All right, so see if you can go ahead and pause the video and do number 4 on your own. All right, so you should have gotten negative 4/5 and positive 1. All right, so there's your factoring part of it. Now, what about in situations where actually you don't have to factor? You can use square roots and use the square root property. Now, there's something in common with all of the problems up above here, and that is you have a variable squared and you have a variable to the first power, y squared, x squared and an x, w squared and a w, p squared and a p. So we have to use factoring or some other method because we cannot combine those like terms. However, in this situation, we don't have that. Notice that our variable is only found once, and in every situation, they're all squared. So in this situation, we don't have to factor. You can, by all means. We could factor this first one out. This is the difference of 2 perfect squares. We could do 14d plus 9, or sorry, not 14, I think I said 4d minus 9. So we could indeed factor that out if we wanted to. Or you can, just like when you solve a linear equation, get your variable by itself, and in this case, get the d squared alone. So I can go ahead and add 81 to both sides. 16d squared is equal to 81. And let me just check here. So if I take 81 and divide that by 16, what did I do here? 81 divided by 16, there we go. So it's going to keep it as that. It does not simplify. Sorry, I'm just getting a different color here. So divide by 16, so you see my steps. I get d squared is equal to 81 over 16. There's nothing I can do with that. Now, to solve for d, I need to take the square root of both sides. So d is equal to square root of 81 is 9, square root of 16 is 4. Now, there's one big thing you have to remember, and that is that this is not just positive 9/4, it is also negative 9/4. When you take that square root, when you physically have to draw on that square root, you need to remember that it's plus or minus, okay? Just thinking back to if we were to say x squared equals 25. Remember that, especially working with those absolute values, we can have x can equal 5, 5 squared equals 25, or x could equal -5. -5 squared also gives us 25. If we were to factor this out, well, then you're more likely to see it because you see those two factors and you do get the positive and negative 9/4 that way. But you can do the square root property, just make sure that it is working with plus or minus. Now, number 6, here I am looking to solve for m squared, so I'm going to divide both sides by -6. And as I take 48 and divide it by -squared, oops, sorry, get back up there, we get m squared is equal to -8. Now, if I go and take my square root here, I'm going to have a little bit of an issue because I can't take square roots of negative numbers, except you guys know how to work with complex numbers at this point. So m is going to equal plus or minus I square roots of 8. Now, square root of 8, we can break that up into square root of 4 and the square root of 2. So that means we are actually going to get plus or minus 2i square roots of 2. So we get imaginary solutions sometimes when you're using that square root property. When imaginary numbers, you will never get those when you are working with factoring. And we'll get into that later too. Number 7, in this situation here, I'm going to go ahead and I'm going to subtract 11 from both sides. So 3/2 x squared is equal to 48. And then we're going to divide by 3/2. So 48 divided by 3/2, I'm going to get 32. So x squared is equal to 32. I'm going to take the square root of both sides. And this is going to give us that x is equal to plus or minus, and 32, we can break that up into 16 and 2. Yes, so plus or minus 4 square roots of 2. So there are 2 solutions. All right, so why don't you guys go ahead and pause the video once again and see if you can do number 8. All right, so we're incorporating some things from earlier in this chapter, and that's working with those radicals. So we should get plus or minus the square root of 9/7, and take the square root of your numerator, which is 3, square root of 7, and then just remember here that you are rationalizing that denominator, and that's how I get the 3 square roots of 7/7. All right, now on to the next part here of completing the square. Now, completing the square is a awesome way to work with quadratics because it makes graphing it out so easy. All right, you are able to find the vertex in an instant when you have it in vertex form, which is this idea behind completing the square. Not to say that you can't graph it when it's also in standard form, but this is a really nice, easy way to really get a location of where it is. So you're going to want to write these steps down, and we'll go through these. So first of all, rewrite. Zoom in on this a little bit here. So the first thing you're going to do is, unlike what we were doing when solving with factoring, where we set the equation equal to 0, here you actually want to get that constant term by itself on one side of the equation. All right, so we want to get that there. Now, to make this nice and easy on ourselves, this next step is really important. Divide both sides by that value of a, if you do have something there, so that you get a value of x squared. So you want this quadratic term to have a leading coefficient of 1. All right, so then what we're going to do is we are going to complete the square. You are trying to make it so that the left-hand side is a perfect square. So essentially, we can use that square root property. How we're going to do that is you're going to take half of that b value, square it, and you will add it to both sides of the equation. We're going to add it to both sides. What we do to one side of the equation, we must do to the other. That's going to create, over on the left-hand side, a perfect square trinomial. So we can factor that out. And at that point, we will see that we can take the square root of both sides. And lastly, we will be able to solve for two cases. And be aware that this is a way for us to also find complex solutions. Factoring does not allow for us to find complex solutions. Okay, this is a way that we can. All right, so let's go ahead and take a look at number 9. And I'm probably going to do 9 and 10. Oops, sorry. I'm going to do 9 and 10 with you guys. And then I'm going to have you try and do 11 and 12 on your own, because I think those look like good ones to try. All right, so first of all, I need to bring that 20 over to the other side. So we've got a y squared plus 12y is equal to negative 20. Now I'm leaving this space there for a reason. I don't have to worry about anything out in front of the y squared, so we are ready to move on to the next step, and that is to complete the square. I am going to be adding a number to the left-hand side and to the right-hand side. That number that we are going to add is 1/2 b squared. So in our case here, we're going to take 1/2 of 12, which is 6, and we're going to take 6 and square it, so we get 36. If I add 36 to the left, I have to add 36 to the right. Now, what this does is over here on the left-hand side, this creates a perfect squared trinomial, meaning that when I factor this out, I'm going to get y plus 6 and y plus 6. Those are identical to each other. Now, over on the right-hand side, negative 20 plus 36, that's going to give us 16. Over on the left, because that's a perfect square trinomial, I can rewrite this as the quantity of y plus 6 squared equals 16. This creates a perfect square over on the left, so that now I can take the square root of both sides. That square root will cancel out with the square, leaving us with y plus 6 is equal to plus or minus 4. So we do have to account for two different situations now. Y plus 6 is going to equal 4, or y plus 6 is going to equal negative 4. So we solve, and I subtract 6, y equals negative 2. Subtract 6 here, y equals negative 10. And those are our two solutions. All right, let's take a look at number 10. First of all, I'm going to bring over that 25, so I'm going to add 25 to both sides. So 7b squared plus 14b is equal to 21. And I now have to divide everything by 7. Okay, every single term has to be divided by 7. Now this is a nice one for us to work with. We get b squared plus 2b equals 3. 7. Yeah, 7 times 3. So now when I am going to yeah, okay. I left a little space right there because there's going to be a number that I am now going to add to both sides. I'm going to take 1/2 of b, which in our case here b is 2, and then square it. Half of 2, 1. 1 squared gives me 1. So we're going to add 1 to both sides. This allows me to factor and get b plus 1 and b plus 1. Now, just a little tip that you might remember from your Algebra 2 days is that 1/2 b right there, that will always be these factors right here. Okay, so you don't have to go through the work of factoring it again. It's always going to be that 1/2 b. All right, this gives us b plus 1 quantity squared is equal to 4. Now, I'm going to take the square root of both sides. So b plus 1 will equal plus or minus 2. So b plus 1 can equal positive 2. B plus 1 can equal negative 2. Do a little work here. B equals, subtract 1, so b equals 1. Subtract 1, and b is equal to negative 3. Now, those are our two answers. Now, don't get me wrong. I mean, in both examples here, 9 and 10, you would be able to do some factoring and to solve them factoring-wise, but in this situation, we are unable to do that. All right, so try and see if you can do 11 and 12, and go ahead and pause the video, and then start it back up and see how you did. All right, so take a look at 11 and 12, and there might be some parts that you struggled with, but that's good. Number one, when you were looking at that adding value, notice in this first one, both of them here, you're adding a fraction, okay? Keep it, don't do a decimal. Make sure that you keep it as a fraction. I'm just doing 1/2 of negative 13, which is negative 13 halves, and squaring that. So you square the top, you square the bottom, you get 169 over 4. Now remember, what I told you was that when you take 1/2 of that b value, that's an important number because that's what gets you that number that's in your factors. So you don't have to reinvent the wheel right there. Your factors are given to you. So as we work through this here, we do get some nice numbers here at the end of the 12 and the 1. Over on number 12, doing the same thing. We're taking that 1/2 of negative 5. All right, so taking that, squaring those values right there, and that's giving us the positive 25/4 that we're going for both sides. And then notice that our factors here of negative 5/2, that's that 1/2 of your b value. And here in number 12, you get the imaginary solutions that we were working with. All right, so last but not least, there is the quadratic formula, okay? Oops, sorry, where's my pen here? Where's my, okay, I'm just gonna click off of there. All right, now your quadratic formula is one, yeah, you guys probably know it. You probably remember, hopefully you remember the song from it. And the quadratic formula does always work, which is nice. It's just long and tedious. I will show you something on your calculator at a later date. But at this point, you need to know the formula. So x equals, if you remember, so the quadratic formula, remember the pop goes weasel. So x equals negative b plus or minus the square root of b squared minus 4ac. Finish it all over 2a. Missed by 2. All right, so there's your quadratic formula. This is a plug and chug type of situation. The downfall on this is that these answers, they don't really tell you anything, especially in the graphing aspect of things. It doesn't really tell you, but the nice thing is it always does work. So you will see me trying to do a little bit of completing the square more often. And I will use quadratic formula here, that hit or miss on that. There are some shortcuts with it too. So here I just want to review this option for you. You look, number one, like with your solving with factoring, you do have to have the function equal to 0. So I would need to subtract my 10k, and you want to make sure you have it in standard form then. So negative k squared minus 10k minus 8 is equal to 0. So my value of a here, so a would equal negative 1, b would equal negative 10, and c would equal negative 8. Now, if I wanted to, if I didn't like having negatives around it, I could essentially divide everything by -1. That's another option for you in a situation like this. When you do it to everything. So now it's plug and chug. So x equals -b. So that means a -10, which will make it positive, plus or minus the square root, b squared, -10 squared, minus 4 times a, which is -1, times c, which is -8, all over 2a, so 2 times -1. All right, so that negative of a -10, that makes that +10, plus or minus. Now, this next part, people make so many mistakes with the quadratic formula just because it's calculating problems with their calculator. Now, -10 squared is 100. Subtract 4 times a -1 times a -8. It's going to give me 68. So I get plus or minus the square root of 68 all over 2 times -1. So that'd be -2. All right, so then I just have to look at here 68. We can simplify this down. So 10 plus or minus 68, we can break that down into 4 and 17. And I'm just double checking real quick here. 100, yes, okay. So this will give me 2 square roots of 17 all over -2. Now, here's a situation where we can divide both by -2. And so we're going to get -5 plus or minus, sorry, the 2 will cancel, plus or minus the square root of 17. So those are my 2 solutions that are there. All right, number 14, if I get everything equal to 0 here, so 6x squared minus 3x plus 9 equals 0. Typically, what I do like to do is I like to get my value of a so that it is positive. I do think that makes for things to be a little bit easier down the road, but it's not something you have to do. So there's my a, b, and c. So x equals -b, so negative of a -3 plus or minus the square root of b squared. Hopefully you're still singing the song. B squared minus 4ac all over 2a. All right, so why don't you pause the video, see if you can calculate what's underneath that square root there for me. All right, so underneath that square root, hopefully you got -2 over 207, which is going to tell you that these are going to be complex solutions. And I can simplify that square root of -207 to 3i, square root of 23. And then now I can divide, simplify 3/12 for both of those. And we should get 3 over 12, so that's going to give us 1/4 there. So 1 plus or minus I square root of 23 all over 4. And there you got it. Now, where the quadratic formula really does come in handy is, when you are starting to work with some application type problems, doing some estimating, so we'll see that later on there. Here you have a function. If any of you guys have done physics yet, you've talked about probably, excuse me, vertical motion, gravity. When you throw something up in the air, it's going to come back down. So here you've got a quadratic that you need to solve for. Now there's different ways that you can approach this. You could use any of the ways that we just talked about it, okay? So the rocket is launched upward with an initial speed of 325 feet per second. Its path is modeled by this equation. Later on, we'll definitely talk about how that does represent this upside down parabola, where h is the height of the rocket and t is the time in seconds. How long does it take the rocket to reach the ground? Okay, number 1, how long? So you are solving for t. Okay, How long does it take? I will tell you right now that a question like number 15 is on your final exam, okay? How long does the rocket take to reach the ground? So when you're talking about that, you're solving for t, how long does it take to reach the ground? Well, think about it. If we're solving for t, you need to put something in for h. So what is the height of this rocket when it hits the ground? Well, that's when h is equal to 0. So now you have this equation of negative 16 t squared plus 325t. We are trying to solve it for when does it equal 0. Now, in this situation, I am going to go ahead and do some factoring just because that's my fastest and easiest way of doing this, because we can take out a t. All right, take out a t and you're left with negative 16t plus 325, and this equals 0. So now we've got, all right, t equals 0. We also have negative 16t plus 325. That equals 0. And now we solve. Well, you got the 1, t equals 0. And then we're going to take and subtract the 325. And negative 325 divided by that by negative 16. And we are left with t is equal to 20.31. So the rocket is in the air for 20.31 seconds. Why is it at the 0? Because that's when it's starting. All right. When you have a rocket that starts at ground level, it goes up and comes back down. Well, right here, here's where your 0 is. That's one solution. Here's your other one, the 20.31 seconds. All right, so there we are with solving quadratics.